This is the 6-1 notes. Your objective is that you can simplify using the properties of exponents. Alright, so kind of continuing on for the warm-up, we're going to be still using these exponents. And what we're going to be kind of talking about today is some of these properties. And these properties are probably things that I would write down, just because it is so kind of helpful to have and to know. Alright, so the multiplication powers property. And what this does is this makes the powers add together. And so the way to kind of see this is 2 squared times 2 to the third. This is the same as 2. And then if you just want to think about the exponents, and the way that we do this is because we have the same base. This is the base term. This 2 and this 2 is what we call the base. Because we have the same base, these powers, these exponents, add together. And so this is the same as 2 raised to the 2 plus 3, which is the same as 2 to the 5th. Alright, I go to the next one. I say, alright, they have the same base. They have a 4 and a 4. So I know I'm going to have a 4. And then I'm going to combine the exponents. So the 5 and the negative 3. So I go 5 plus negative 3. And so this gives me 4 to the second power. It even works with variables because we, again, have that same base number. That kind of, some people like to think of it as the big number. The big number there is the 4. The big number here is the x. So I have that x in common. And when I'm multiplying the bases together, I add them together. So it's 4 plus 3, which is x to the 7th. Now, as you can probably guess, if we have addition, we must have some way of subtracting. And we do. The way of subtracting is, if multiplication was addition, then division is going to be subtraction. The same kind of basic rule applies, that we need to have the same base in order for this to happen. And so I look at my first one, I go, alright, I have 2 as a base, and I have a 2 as a base. Alright, that means I can combine powers. And so I go, this is the same as 2, 8. The number on top, the exponent on top of the fraction bar, always comes first. So 8 minus 3. And so we get 2. 8 minus 3 is 5. Alright. And, well, I'll get to that when we get to that. So for the next one, I again look and I say, okay, I got the same base. I got a 3 and a 3. So my base here is going to be a 3. And then I go 7, because the one on top goes first, minus 2. And so this is 3, and 7 minus 2 is 5. Alright. Now I look at the next one. And again, I check and I say, yep, they have the same base. So I go y. 5 minus negative 3. And so I get y. 5 minus negative 3 is the same as 5 plus 3, so I get 8. Now you could probably start thinking, alright, we can add, we can subtract. Are we able to multiply? And the answer is yes. And that's using the power property. The power property lets us multiply. And so I go, alright, 3 to the third squared. And this kind of seems like I like to think of it as nesting. It's a little bit what it is. If you're into computer science, you might kind of get that a little bit. But it's kind of, we have something to a power, and that whole thing is taken to a power. And so a way to think about this is 3 to the third times 3 to the third. And why that helps is now if you get the multiplication property, you can now understand, oh, this is how it multiplies. Because I have 2 of them, this becomes 3 to the 6, because 3 plus 3 is 6. But also, 3 times 2 is 6. Alright, if I go to the next one, I have 4 squared to the 8th power. And so I could write out 4 squared 8 times, but that just takes a long time. And so we're kind of quickening this a little bit by going, okay, this is the same as 4 to the 16th. All right. Now we do the next one. All right, a to the 4th raised to the negative second power. And what that gives us is we go, oh, okay, this is a 4 times negative 2, so 4 times negative 2, that gives me that a is negative 8. Now, something that we haven't really dealt with up to yet is this whole, I guess we talked about it in the warm-up, is the whole negative exponent thing. We don't like the negative exponents because we kind of can't really comprehend them, because we're like, oh, to the negative 8th power, what does that even mean? And so whenever we're writing these, we want to always try and make sure that we have all of our exponents being positive. And so what that tells us is we need to flip to the other side of the fraction bar. And so this is a to the 8th. All right. Now, anytime that we're doing stuff like this, there's always kind of a be careful of type thing, and this is an example of it. Looking at these two, you might inherently not really think there's any big difference between them. You might be like, okay, negative 4 squared, and in parentheses, negative 4 squared. And what the difference here is this negative right here, isn't being influenced by this squared. So it's completely separate of it. And so what that kind of means is I go negative, and then I do 4 times 4. And so this gives me negative 16. How that's different is in this one, the entire negative 4 is being squared. And so this winds up being negative 4 times negative 4. And so I get 16. All right, let's do a little bit of practice with this. Evaluate tells me that I should have some type of number answer. And so as I go through this, I'm going to make sure that I'm kind of getting some kind of number answer. And so I start off with, I go, okay, 5 to the negative 4th. Oh, that negative 4, we don't want there to be a negative exponent. And so this transforms into 1 over 5 to the 4th. And if I go 5 to the 4th, 5 times 5 is 25. 25 times 25 is 625. So this is 1 over 625. And you might be tempted to be like, I'm just going to do 1 or 5 to the negative 4th in the calculator, and you're going to get some random decimal number. And your decimal number is actually going to probably be longer than 1 over 625. And so it's very important to kind of be able to do these by hand. All right, let's do negative 5 to the negative 4th. And so this is the same as 1 over negative 5 to the 4th. Notice how I keep that parentheses around it, because if I don't want to make sure that I don't kind of exclude that negative because it's being included. And so this is negative 5 to the 4th is 125. Negative and negative make a positive. Positive and positive make positive. So this is 1 over 625 as well. All right. Looking at number 3, the first thing that I kind of noticed that's different from what we were doing up above is that the bases are different. I have a 7 and I have an 8. And you might have just been like, wait, no, you have a negative 8. No, I actually have an 8. That negative isn't necessarily associated with this 8. It's going to influence the 8, but it's not dealing with the bases of this. And so I am going to resolve these independently. I'm only going to work with the base 7, and then I'm only going to work with the base 8 stuff. So when I do this, if I start with the base 7, oh, this 7 is to the negative first power. So this is 1 over 7 to the first, because I want to have that as a positive exponent. Now I can deal with this base 8. And this base 8 is a 1. And so this is times, and then I'm going to do this part in parentheses because I'm simply talking about what's happening in this negative 8. Negative, and this 8 to the 0 power is 1. And so what this winds up being is 1 over 7 to the first is 7, times negative 1 is negative 7. So I get negative 7. And where you have a lot of confusion is whenever people kind of think, oh, there's a negative here, I need to flip over the fraction bar, they want to flip this 8 as well. They want to put the 8 on top, or they want to put it underneath another fraction. No, the 8 is separate from what's happening with the 7. All right, let's go to number 4. Again, I'm going to kind of evaluate these two different bases, so the base 8 and the base of negative 4. I'm going to evaluate those separately from each other. And so the 8 to the negative first tells me I need to go 1 over 8. And then I do negative 4 to the 0. Negative 4 to the 0 is 1. So I go times 1. And that equals 1 over 8. All right, number 5. Again, working kind of separate from each other. This 2 is the base, and this 3 is the base. The negative isn't being influenced by the exponent. And so I go, okay, this 2 is to the negative 4, so this is negative 1, because we're getting rid of the stuff on top of that negative stays, over 2 to the 4th. And then I go, all right, this 3 is to the negative third. Oh, that means it needs to go up on top. So I need to go 3 to the third. And so this means I go 3 to the third, 3 times 3 is 9, times 3 is 27, times negative 1 is negative 27, over 2 to the 4th power is 16. All right, number 6. Looking at my bases, I got 6, and I got negative 1, so they're going to be evaluated separately. So I have 1 over 6 squared. Now I'm going to do the negative 1 to the negative 4th, so times negative 1 to the 4th. So this gives me, kind of the easy one is 6 squared, that's 36. And then negative 1 to the 4th, that's going to be positive 1, times 1 is 1. Alright. Alright, in exercises 7 through 20, simplify the expression, write your answer using only positive exponents. So, again, whenever we're working through these, we are evaluating each base separately. And this explicitly tells us that we need to have positive exponents. And so that informs us, okay, anywhere that we have a negative exponent, we need to kind of fix that issue. And so I start with the 7. Why? Because it's just kind of the first one I see there. And you can kind of take a moment and you can identify, okay, I have a 7, I have an M, and I have an N. And that can be helpful to make sure that maybe we're not going to do any of that quotient property or the multiplication property, anything like that. And so I start off with, and I go, okay, 7 to the negative second. Now that tells me I need to put that on the other side of that fraction. So it's 7 to the second power. Now I'm going to do the m to the 0. M to the 0 is 1. N to the negative 4th, that negative 4 tells me we're on the wrong side of the fraction bar, so I need to take it up above. and I go n to the fourth. Now I need to simplify this. 1 times 1 is 1, times n to the fourth is n to the fourth, and 7 squared is 49. Alright, now I go on to number 8. I identify my bases, so negative 9, j, k, and 2. And I start off. I go, okay, negative 9 to the 0 power, that's 1. J to the negative first says that I'm on the wrong side, and so I do j to the first. K to the negative fourth tells me, again, we're on the wrong side of that fraction bar, so this is times k to the fourth. 2 to the 0 tells me that this is 1. And so my answer is 1 over j k to the fourth. And you could put j to the first if you really wanted to, if you kind of want to make sure that you didn't lose it. That's okay. Alright, number 9. Again, identify my bases. Alright, I have 5, I have w, and I have y. Alright, now none of those are the same. So 5 to the negative second. Oh, I'm on the wrong side of the fraction. So it's 5 to the second, 1 over 5 to the second. W to the 0, anything to the 0 power is 1. Y to the negative 10th tells me that we're on the wrong side of the fraction bar. So I move the y, and that turns it into a positive exponent. 1 times 1 is 1, times y to the 10th is y to the 10th. Over 5 squared is 25. Alright, number 10. Again, identify my bases. Okay, t, 8, s. T to the negative fifth, I'm on the wrong side of the fraction bar, so I do 1 over t to the fifth. And you may be wondering why I always do this 1 up top. I always find that if I don't do that and everything happens to be on the bottom, I leave that off, and I don't have kind of what that true fraction is. So that's kind of the reason I do that, and I just kind of am multiplying the entire time. 8 to the negative second tells me on the wrong side of the fraction bar, so I do 8 to the second. S to the negative third, again, we're on the wrong side of the fraction, so it's s to the third up on top. And I go 8 to the second is 64, and then s to the third over t to the fifth. Alright, let's look at number 11. Alright, looking at the different bases, I have 3 to the negative second, I have a to the negative first, 9 to the negative first, b to the negative second, c to the 0. All of them appear to have different bases. And so I go, okay, I'm going to start off with, 3 to the negative second. We're on the wrong side of the fraction bar, so this is 3 squared. A to the negative first, again, wrong side of the fraction, so I change this to a to the negative first, or whoops, not negative 1, positive 1. Alright, did everything on top. Now I'm going to start on bottom. 9 to the negative first, we're on the wrong side, so this is 9 to the first power. B to the negative second, we're on the wrong side, so times b to the second. C to the 0 stays down below. C to the 0 is 1. So I simplify these, or multiply everything across. So 9 to the first is 9b squared over 3 squared is 9a to the first. And you may notice right here that they both have the same number now. They both have a 9. And what can happen with this is they actually cancel each other out. And so I'm left with b squared over a. And that kind of becomes a kind of an important thing later on that makes it kind of a little bit easier, actually. All right, let's go on to number 12. Identify my bases. Okay, I got 17, I got x, I got y, I got 4, I got z. So I'm going to work with those. 17 is just to the first power, so it stays where it is. x to the 0 is 1. Y to the negative 8th tells me we're on the wrong side of the fraction bar, so I move it down below. So I have y to the 8th. 4 to the negative 2nd, again, we're on the wrong side of the fraction bar, so I take it up top. 4 to the 2nd. Z to the negative 6, we're on the wrong side of the fraction bar, so I take it up top. And I try to solve. 17 times 1, so I got 17. 4 times 4 is 16. Z to the 6th divided by y to the 8th. This winds up being 272. 272 z to the 6th over y to the 8th. Alright. Number 13, we're using that quotient property, or the product property, sorry. So p to the 6th to the 3rd power, this is the same as p6 times 3, which is p to the 18th. Number 14, this is the same as q negative 4 times 5, which is q to the negative 20th. And we're specifically told that we need to have positive exponents, so I need to put this on the other side of the fraction bar, so q to the 20th. 15, base of 5, base of 5. Alright, they can combine. This is the product property. So we go 5 to the 3rd plus negative 7. So it's 5 to the negative 4th. And so this is 1 over 5 to the 4th, which is 1 over 625. We did that earlier. All right, number 16. Negative 4 times negative 4 squared. Or negative 4 to the negative 2nd power. Now, it's really tempting to think of these as possibly having the same base, and they effectively do. Because we can kind of think of this negative 4 as being its own set of parentheses just for this purpose. And that might be a little bit confusing to some people, because earlier I said, oh, this 4 is independent of this negative. But whenever it comes to this, whenever we're showing it like this actually is a negative 4 times this negative 4 squared. Now, however, if I would have put a squared right here, this would be a completely different story. But because it's just by itself, this winds up working out. And so I can think of this again as being its own set of parentheses and having a 1 with it. And so I go negative 4 times negative 4 to the negative 2nd. This is negative 4, in parentheses, 1 plus negative 2, which is negative 4 to the negative 1st power. Oops, and this is in parentheses. And so this is negative 4, 1 over negative 4. That's what I was going for. You still might be like, yeah, but was it really? Like, are we sure that this actually works out the way that we just said it did? And that's a really good question to ask. And so we could write it out, and we could keep these separated from each other. We could say, hey, you know what? No, these have different bases. We're going to say these have a different base. And so we say, okay, this is this, and this is that. All right. I'll continue on with that idea. I'll go, okay, negative 4 over, because this negative 4 is to the negative 2nd, so that tells us we're on the wrong side, negative 4 squared. And so we have negative 4 over negative 4 squared is 16. And if I reduce this, I get negative 1 over 4, which is the same as 1 over negative 4. That negative can be in either position. All right. Number 17. Number 17 is kind of fun in that you can kind of approach it in different ways, but you'll get the same answer. Um, and probably your best bet is to follow PEMDAS. And so you start off and you go, okay, in parentheses, no, any exponents? Well, yeah, everywhere, but nothing's happening with them really. Is there any multiplication? Yeah, we're going 7 over 4 times x squared. And so this is the same as going, okay, x 7 plus 2 over x to the fourth. And if you struggle with this, this x over 2 is really x over 2 over 1. X to the second over 1. And so we go x 7 plus 2 is x to the ninth over x4 is x to the fourth. And so we're still not quite done yet because this is the same as x 9 minus 4, which is x to the fifth. All right, let's go to number 18. Number 18, we have y to the fifth times y to the third over y squared. Again, follow PEMDAS. And this one actually has a specific PEMDAS to it that you might not inherently know, in that this top actually has a set of parentheses around it. And so that tells you, if you can, address the top first. So we go y to the fifth times y to the third, so this is the same, or this is v, not y. V 5 plus 3, because that's the product property, over v squared. All right, so 5 plus 3, v to the eighth over v squared. And we're still not done yet because these still have the same bases. And so I have, this is the same as v 8 minus 2, that's the quotient property, and so we got v to the sixth. All right, let's do these two. Now, these two seem very kind of intimidating, and I get that. But what's really kind of, I guess, fun, is, this is the right term here, is that they actually wind up being a lot kind of simpler as long as you kind of break it down into parts. Now, the first kind of big thing about these that's really kind of confusing and really causes kind of a lot of issues is, especially for like kind of you getting through this, is saying, oh, right, I need to, there's these squares on here, and that's really making things kind of really difficult for me. And so kind of the thing to do is we're going to distribute this 2 to absolutely everything. We're going to use that power property to help us with this. And so I'm going to rewrite this. And so this is the same as saying 5 squared, because there's a 1 right here, and 1 times 2 is 5, or 1 times 2 is 2. And then I go, okay, now I'm going to do the x. This x to the negative 4. Negative 4 times 2 is negative 8. Now I do the y. Y to the third is times 2 is 6 over, this 2 becomes 2 squared. This x becomes x to the fourth because it's 2 times 2, not because it's 2 plus 2. 2 times 2 still is 4. And then I go 0 times 2. Okay, my y is still 0. Then I'm going to do the other side as well. I go, all right, 4 squared, x squared, y squared over y to the sixth. All right, I go ahead and I look through, and kind of one thing that I notice is that I have a negative somewhere. Specifically, let me grab another color. This one. So let's go ahead and rewrite this. And we'll also evaluate the numbered ones. So 5 squared is 25. This x is moving to the other side, so kind of continuing along, I have y to the 6th over 2 squared is 4. I'm moving this negative 8 down, so it becomes x to the 8th, x to the 4th, because this one stays where it is. Y to the 0, we can do that one right now. That's just 1, so times 1. There's kind of some multiplications in here if you need to see that. Times 4 squared is 16. This is x squared. This is y squared over y to the 6th. And now what I can start to do is I can actually kind of multiply everything together. And because these are going to combine, yes, but we're going to have kind of a few things happening here. So let's go ahead and multiply some of this stuff. So 4 and 16, this reduces down. This makes it 4, and this makes this 1. And so I go 25 times 4, that's 100. X squared comes over y to the 6th, and y to the 2nd makes y to the 8th over x to the 8th times x to the 4th makes x to the 12th. And then I got a y to the 6th. And we're still not quite done yet, because we have some common bases. So we still have these x's and these y's. And so the 100 stays as it is. And I kind of do this a little bit off to the side. I go, okay, x2 minus 12 is x to the negative 10. And what that tells me is I need my x to be on bottom with that 10. And that makes it so it's a positive number. And then I do my y. Y8 minus 6, that's y to the 2nd power. Okay, this is y squared up top. And that's it. We have all of our bases reduced as far as we can, and all of our exponents are positive. Alright, now we're going to do the same thing with number 20. So again, I'm going to distribute this 4 to kind of just make life at least look a little bit easier. And so I go, okay, this is 2 to the 4th, because this is a 1, right? And 1 times 4 is 4. This is still a to the 0. B to the negative 4, so that makes this b to the negative 16. Over 3 times 4 is 12, so b to the 12th. Times a to the third power is a to the 9th. This is b to the negative 6th. This is 3 to the 3rd. B to the 12th. A to the negative 12th. Okay, kind of big issues that I see is I want to move this negative 16. I want to move this negative 6. I want to move this negative 12. That way I have some everything's positive exponents. I'll also evaluate some of these numbers as we go along. 2 to the 4th is 2 times 2 times 2 times 2, so that's 16. A to the 0 is just 1. That's everything because the 16 is moving. B to the negative 16 is moving. So I got b to the 16th times b to the 12th times a to the 9th. This b to the negative 6 is moving, so I move it down. I'll be moving it down. 3 squared is, or 3 to the 3rd power is 27. B to the 6th times b to the 12th. The a needs to move back up top, so a to the 12th. Alright, now we're going to go ahead and kind of combine things kind of in one we're going to combine everything on the left side, combine the stuff all on the right side, and combine the two together kind of all at once. And so I have 16, a to the 9th, a to the 12th is a to the 21st. B to the 16th, B to the 12th. That's B to the 28th. The 27, bring the 27 over here, and B to the 28th, B to the 6th, B to the 12th, that's B to the 18th. Kind of one final step here of combining these B's that came together. 16, A to the 21st, that's staying the same. We got 27, B, 28 plus 18 is 46. Alright, that concludes the lesson. Check with your teacher on your assignment. Have a good one.